4-stroke internal combustion petrol engine are one of the most basic engines used in cars and bikes. As the name says, it consists of 4 strokes and the combustion of fuel takes place inside the engine. It uses petrol as the fuel. Now, let us look at the different parts of 4-stroke IC engine. It has a cylinder block and a crankcase. These two parts will give the basic structure to the engine. At the top, we have a cylinder head. This cylinder head holds the inlet and outlet valves. The valve operates based on the cam and follower arrangement. The cylinder head also holds a spark plug, which is used to ignite the fuel inside the engine. Inside the cylinder block, we have the piston. This is the heart of IC engine. The piston travels between the top dead center and the bottom dead center. The top dead center is the position of piston which is farthest from the crankshaft, and the bottom dead center is the position of the piston which is nearest to the crankshaft. These two are like the end points of the piston movement. The piston is tightly placed inside the cylinder block so that the fuel does not leak through the piston. This piston is then connected to the crankshaft through the connecting rod. What is a connecting rod? The connecting rod is a simple rod connected between two moving parts. In this case, it is connected between the piston and the crankshaft. The crankshaft is a component that is used to convert the reciprocatory motion to rotatory motion, that is, the up and down movement of the piston to the rotary motion. This rotary motion is very important as it is used to drive the wheels of your car or your bike. But the crankshaft is not connected to the wheels directly. It is connected to the flywheel and then to a series of gear arrangements and finally to the road wheel. These are the different parts of 4-stroke petrol IC engine. Now, let us look at the operation. This type of engine has 4 strokes. A stroke means the movement of piston from one dead center to another dead center. For example, if it moves from top dead center to the bottom dead center, it is considered as 1 stroke. Here we have 4 such strokes. They are called intake stroke, compression stroke, power stroke and exhaust stroke. Let us understand each stroke now. At first, the intake stroke. In this stroke, the fuel is sucked into the piston. The energy to move the piston down is provided by the batteries. So, the piston moves down towards the bottom dead center. While moving down, the piston creates a partial vacuum inside the cylinder. This vacuum draws the air-fuel mixture into the cylinder. The inlet valve will be opened at the right time using the timing mechanisms to allow the right amount of air-fuel mixture. We can represent this on a pressure versus volume graph. As the inlet valve is open, this stroke takes place at atmospheric pressure. This is denoted as straight line AB on the graph. At the end of the suction stroke, the inlet valve will close. Now, the piston starts moving upwards. As the piston moves towards the top dead center, the air-fuel mixture gets compressed. Near the top dead center, the air-fuel mixture is highly compressed. At this point of time, a spark is produced by the spark plug. This spark will ignite the fuel. This is the stroke number 2, the compression stroke. During this stroke, the inlet and outlet valves are closed. The cylinder is isolated from the surrounding atmosphere, or the air-fuel mixture inside the cylinder is not interacting with the surrounding. This state is known as adiabatic state. So, the air-fuel mixture undergo adiabatic compression. This process is represented as curve BC on the graph. This is stroke number 2. Now, we will look at third stroke, the power stroke. As we have ignited the air-fuel mixture, the combustion will occur inside the cylinder. The piston is at the top dead center and it stays there for a very short time. The combustion of mixture will take place at this point of time at constant volume. This constant volume combustion process is represented as line CD on the PV graph. Right after the combustion, the burnt gases will exert a large amount of force on the piston, which will make the piston to move downwards. This is the stroke of the piston powered by the fuel. The piston will move towards the bottom dead center. This case is similar to third stroke because the expansion of burnt gases occur adiabatically. At this time, both the inlet and outlet valves are closed. The fuel inside is not interacting with the surroundings, so it will be an adiabatic expansion. This process is represented as curve DE on the PV graph. Towards the end of power stroke, the outlet valve will open up. This makes some of the exhausted gases to move out of the cylinder. This will also bring down the pressure of the cylinder to atmospheric pressure. The drop in pressure is denoted on the PV graph as line EB. On reaching BDC, the piston will start moving upwards again due to the flywheel's momentum. Now, the burnt gases are used up and exhausted. It has done its job of pushing the piston down. The piston moving upwards will push out all the exhaust gases out of the cylinder. This stroke is known as exhaust stroke. Now, if we observe, the outlet valve is open, so the system is no longer isolated. This process takes place at atmospheric pressure. This is represented as straight line BA on the PV graph. We have come back to where we have started. The cycle can repeat from this point. Like this, the 4-stroke engine will repeat the cycle over and over again to run your bike or car. As we saw, the 4-stroke engine runs on a thermodynamic cycle known as Otto cycle. In Otto cycle, we have adiabatic compression, adiabatic expansion, the suction of fuel and exhaust of burnt gases at atmospheric pressure, and the combustion at constant volume. This is how the 4-stroke petrol engine works based on Otto cycle. To sum up, we learnt about the parts of petrol engine, 4 different strokes such as suction stroke, compression stroke, power stroke and exhaust stroke. In the next video, we will look at 4-stroke diesel engine. See you there.